CloudDB, shaping your new normal.
Good morning, everyone. My name is Ashwini. I am from Product Management Oracle. Welcome and thanks for joining the APAC Groundbreakers 2021 virtual tour session. Today, we'll be seeing how we can leverage observability and management services to manage the OKE platforms. This is our agenda. We'll get to know what's an OKE, overview of observability and management, overview of application performance monitoring, and how it can help in troubleshooting the Kubernetes engine, overview of logging analytics, quick demo, and resources, and Q&A. Oracle Cloud Infrastructure Container Engine for Kubernetes is a fully managed, scalable, and highly available service that you can use to deploy a containerized application to the cloud. Container Engine for Kubernetes uses Kubernetes, which is an open source system for automating deployment, scaling, and management of containerized application across clusters of hosts. Kubernetes groups the containers that make up an application into logical units, which are called pods for easy management and discovery. A Kubernetes cluster is a group of nodes, which are nothing but machines running applications. Each node can be physical machine or a virtual machine. Having created a cluster using Container Engine for Kubernetes, you can use OCI services to view and search the logs of applications running on worker node compute instances in the cluster. We have Oracle Cloud and Observability and Management platform, which consists of suite of integrated services that provide full stack visibility and rapid performance insights for any technology which is deployed anywhere. Our platform helps you cope up with the complexity of your evolving IT estate by enabling you to understand exactly what's going on and take necessary action, allowing you to both prevent the problems by taking proactive action and also react more quickly when unexpected problems arise. We have eliminated the dozens of tool sets by providing an integrated platform for all telemetry, eliminating the data silos and enabling analysis across all types of data, such as real and synthetic end user monitoring data, metric data, trace data, log data, and application and business data, etc. We have made possible cross-tier view of applications, databases, and infrastructure performance from end user to disk for both cloud native and traditional technology. With built-in AI and machine learning, it can easily detect anomalies and perform remediations in near real time. These solutions provide as easy to use cloud offerings that allow you to get started within a minutes. Although the solutions are provided in Oracle Cloud, they support monitoring and management of software running anywhere, whether on premises in your own data centers or on Oracle Cloud or on any third-party cloud. With our solutions, you have maximum choice of selecting the software deployment model and platform that best suits your needs without compromising your choice of observability and management toolsets. Finally, we recognize that even though it is advisable to reduce the multiplicity of management tools in the expertise, and we are trying to help with that, enterprises will still end up with more than one solution. To end that, we have embraced interoperability standards of data exchange and the collection from the cloud native computing foundations such as cloud events and open tracing. We also support open source data collectors like FluentD to help unify data collection and consumption. Some of our foundational services, such as monitoring, notification, and events, are complemented by these additional services in our platform, and which includes logging analytics, APM, database management, operation insights, and etc. So, what is application performance monitoring? This is a service in our platform of observability and management, which provides a comprehensive set of features to monitor application and diagnose performance issues. Some of the features include distributed tracing, wherein it collects and processes transaction instance trace data using APM data sources, open source traces, or directly using APM. Another feature is synthetic monitoring, which evaluates the availability of your application by testing it periodically using multiple vantage points, which ensures the early detection of availability and systemic performance issues. Another feature is real user monitoring. This provides an insight into experience how the end user directly interacts from the browser. Next feature is server monitoring, which collects performance and usage metrics from monitored application servers. In addition, you can see use Oracle defined dashboards provided with APM for a comprehensive view of the performance. So in APM, the main feature is open. One of the main feature is open tracing. This is like, for example, anytime there's a request made from a browser or directly to an app server, the browser or app server looks to see if there is a trace ID present in the request headers. If not, it'll create the trace ID. This is the record identifying a transaction. Now, each service component in your application stack that receives a request to do a job for this transaction does two things. It creates a snap ID to reflect it and doing some job for the transaction, and declares it was doing a job for the trace ID. It only keeps track of its own job. Was it completed? Did it succeed? And what time did it take? Which, for example, but many more details could be added if we desire. Now imagine that all the microservices in our application stack send out these reports. They are sent off to microservice immediately, so they don't create overhead. And an agent picks up the reports, which are nothing but spans, and sends them off to APM. The APM service now reconstructs, aggregates all the reports by trace ID, so you can follow the progress of your transaction in a full manner. This is happening outside of your application. It is completely based on open standards. So even if your application is using some technology we do not have a full APM agent for, there's a high possibility that's an open source tracer you can use. In APM, all the span and trace events gets processed and stored. You can analyze all the trace span data via our Trace Explorer, and the system is built to deal the huge amounts of tracing data, meaning you don't have to worry about sampling the reports, which are span events you would like to send over, but get a full view of everything that happened. Analyze traces, aggregate by service, operation, SQL, etc., using a very simple query language in the Trace Explorer. Prometheus is a open source systems monitoring and alerting toolkit. The Prometheus, it is a cloud native computing foundation, which was a hosted project after Kubernetes. Using AppDex, it's an open standard which is developed by alliance of companies for measuring the performance of software applications. As stated before, we have a full-fledged Java agent you can deploy on your JVMs. But if you're already instrumented your applications to produce trace span events, the agent can simply be used to collect and aggregate these events and send them off to APM. You can also use an open source agent like Agar, Zipkin to reconfigure it and send the trace data to our collectors, or use a metric API so to send the metric data about the health and performance of the application infrastructure that's involved. This helps in distributed tracing and generating or creating metrics using the collectors. The next service which helps to troubleshoot any our OKE environment is logging analytics. This is one of the popular service where it lets you search, analyze, correlate, visualize, and monitor all the log data from an application and system infrastructure. Logging analytics provides multiple ways of gaining operational insights from your logs. You can use Log Explorer UI, aggregate log information into dashboard, utilize the APIs to ingest and analyze data, integrate with other OCI services as well. Using LA, we can search the logs and drill down to specific log entries to resolve problem quickly. We can perform advanced analysis of the log data to find out root causes, find potential issues, detect anomalies, and fix the issues. For this we can make use of advanced analysis tools such as cluster, link, cluster compare, etc. A saved search can be used to repeat the search at a later point, to set up a scheduled task, to run the search, to set up alarms on the search, and also to create custom dashboards. So custom dashboards are created by adding Oracle defined or user defined widgets. The interactive visualization provides several possibilities to slice and dice the data. The cluster feature is used to reduce millions of log entries down to a small set of interesting log signatures, making it easy for you to review. The cluster feature in log analytics is a good solution when you have a large number of volume of logs and you don't know what to search for. Cluster has the following benefits. It uses machine learning to group the logs that have similar structure. It doesn't require you to learn a query language. It doesn't require you to specify or supply any parameters like the number of clusters. And it runs very quickly on large data sets. LA has several features that allows you to find insights using machine learning. One another feature of LA is Link. Link lets you to perform advanced analysis of log records by combining individual log records from across log sources into groups. This is based on the fields that you have selected for linking. You can analyze the groups by using the same fields as the ones you used for linking, or additional fields for observing unusual patterns to detect anomalies. We can also create custom dashboards using the dashboards page by adding several Oracle defined widgets or the custom widgets which we create. We can also create a duplicate of one of the available out of the box dashboards and customize it to meet our requirements. The Oracle defined dashboards gives us an overview of the analysis of some of the important logs. For log analytics, there are several ingestion methods available. Typically, you would select one of these methods depending on your use case and how you are able to access the logs. It includes setup continuous log location from your host using management agents. We can also upload logs on demand. This is useful when you have log data from very old applications, that aren't supposed uh, to be supported by the management agent, or you want to load a log file a single time to analyze them. You can also collect logs from your OCI object storage bucket. We can also ingest logs using other OCI services by service connector. The service connector is used to identify your OCI service as a source of the logs and OCI logging analytics as destination and enable the log connection. For all the log sources, we have support with understanding of a log type and format. This is also intelligent enough to automatically classify the error categories. For OKE, we can make use of FluentD. FluentD is open source data collector software. It has components which work together to collect the log data for the input sources. It also transforms the logs and routes the log data to the desired output. You can install and configure the output plugin for FluentD to ingest logs from OKE environments into OCI. So in this diagram, you can see with all the Kubernetes logs, for example, the Docker logs, access logs, application logs, it is given to this FluentD uh, plugin, which in turn sends the data to the OCI logging analytics as an output plugin, and that thus we can visualize all the data inserted in the logging analytics. This will be further enhanced in our future releases to automatically detect the entities of the cluster of Kubernetes engine and create the and also have separate log sources for all the Kubernetes logs we have instead of defining them, which is the present situation. With this, I'll be concluding the session. Now let us go over the demo. So let us log into the OCI console and let us see how we can quickly create a Kubernetes cluster. So here, this is some of the sample clusters which is created in my compartment. So let us take an example of this to show what happens when we create a cluster. So it is a very simple process of creating a cluster. You have to launch. You have to launch the workflow, and it requires some of the parameters to be given. For example, if you have any specific ask for the CPUs and memory, you can specify that, and you can specify the number of nodes you need, and then it will quickly create the cluster for you. Here, let us take this cluster which is created. So for this cluster, we have one node pool. A node pool is a subset of worker nodes within a cluster that all have the same configuration. The node pools also enable you to create pools of machine within a cluster that have different configuration. For example, you might create one pool of nodes in a cluster as virtual machines and other pool of nodes as bare metal machines. So a cluster must have a minimum of one node pool, but a node pool need not contain any worker nodes. So here in this node pool, we have total 3 worker nodes. So now let us click on this node pool and see the worker nodes. So worker nodes is in a node pool are connected to worker node subset subnet in your VCM. So these are basically the worker nodes. So these on these worker nodes, For example, now we want to monitor these worker nodes as part of our OKE cluster. So by default, Oracle Cloud Agent gets installed on all these worker nodes. So we can enable this management agent plugin for us to enable the observability and management services. So here, if you see on this Oracle Cloud Agent, the management agent plugin is running. So now, once this management agent plugin is enabled, now we also this management agent plugin is a generic plugin for all our services in observability and management platform. In this exercise, we are going to enable the plugins used for uh, logging analytics and APM. So let us go to management agents and select our compartment. So this is our agent, the one which is part of our OKE cluster. So if you see, so since all the plugins are depth, if you see, we have enabled APM, Prometheus, Scraper, and Logging Analytics service. Only after enabling these plugins, so we can see we can enable or set up monitoring for this OKE cluster using our logging analytics and APM. So once these plugins are enabled, let us go to logging analytics service. For that, we can go to observability and management, logging analytics. As soon as we create or set up the logging analytics plugin as part of the OKE cluster, some of the entities part of the OKE cluster gets auto created. That we can see in the entities. Those are called the entities in logging analytics that we can view in the entities section. For that, let us go to administration and click on the entities. So here, if you see, all these entities gets created as soon as we select the plugin in the management agent. So let us see how it is done. So once you click on this entity and you enable the agent as part of this entity, then you can also associate all the log sources present in logging analytics for which you need to collect the logs. These are some of the entities which is part of our cluster. For here, this is one other entity. So if you see, there are different entity types as well. This is a host entity, this is the agent entity, and this is the VCN network interface card entity. So since we enabled the plugin, all these entities gets auto created. Now let us see how it is collecting logs from our log explorer view. This is the log explorer view of logging analytics where we can see the log data. This has basically a few main components. This is the time range which we can select. This is the query bar, this is the fields panel, this is the visualization panel, and this is the main section where based on the query we give the data is displayed. Now let us consider our entity as part of the setup. So we can filter our entity logs by doing a simple search. So in this, I'm going to select some of the entities of our cluster. So based on our selection from the fields panel, the query gets updated, and we get all the logs which have started getting collected in our logging analytics. So this can be further used to do any kind of analysis on the data we have. Here, for example, we are taking the uh, OCI audit logs for our OKE cluster, and we see there are a lot of logs getting collected. And on this, we can run our advanced machine learning analysis. For example, let me run the cluster technique on these logs with this set of logs. For example, this is around 405 logs. We got one cluster. So like this, if we have a large set of logs, for example 1 lakh or 3 lakh plus logs, when we click on the analysis and click on the cluster, it quickly segregates the logs into clusters, potential issues if any, and if any outliers, and if any trends. So in this case, we can see from our OK cluster with the logs collected, this is one of the cluster, and this seems to be a normal log which is been collecting. Like this, we can create a lot of log sources to collect our logs. So these were the sample logs that were collected from our environment. Now, let us go to um, application performance monitoring service of logging analytics. So we've already opened it here. So this is the home page of APM service. Here, these are some of here the with our Kubernetes cluster and the applications which is deployed on our Kubernetes cluster, we can add that application to set up monitoring using our APM. Here, some of the main components are dashboards. We can use dashboards to visualize, explore, and analyze application data to easily interpret the charts. Dashboards are data visualization tools that gather real-time data for various tiers of application and then display them in the charts to quickly identify the outliers and take corrective action. We can also use all these Oracle defined dashboards or widget or create our own custom dashboards which meets our specific requirements. Here the app server, as part of this dashboard, let us see the app server. For example, let us see this app server dashboard. In our Kubernetes cluster, if there is any app server deployed, and if we select that app server, it enables us to analyze the resources used by our application servers, and it also helps us to understand the resource constraints and requirements. For instance, you can monitor this dashboard to analyze like heap and CPU usage of our application server. So some of the other parts of our dashboards are the monitors. So basically these monitor dashboards provide an overview of our synthetic monitors runs. So what this displays is successful or failed monitor runs. The monitor runs are critical vantage points, low and load time and so on. This enables you to proactively find and fix the issues before it is impacted. The monitor dashboard also displays the list of monitors in this domain, and you can click on the name of the monitor and navigate to each of the monitor details page. So these are some of the monitors present in our dashboard. So these are the vantage points defined for this monitor. And we can see the definition. It runs every 5 minutes and timeout, and it's the type of scripted browser. One another out of the box dashboard, which is very useful as part of APM, is real user monitoring dashboard. This provides an insight into the performance of our web applications and user experience as well. The web application drop-down lists us to select a subset of data of which you want to display the widgets like app text, browsers, operating systems, devices, and etc. This also enables us to measure the speed and performance of a web application and take corrective action to enhance the user experience. The real-time monitoring displays the geomap widget, which allows us to select a metric in the metric drop-down list and view high and low values by continent and uh, for continent and for the selected metric. So this gives the data for that particular monitor. Next, one other feature of our APM is the Trace Explorer. This is a Java tracer, which also referred as a APM tracer, which supports open tracing specification and enables us to capture all the traces, spans, and JVM metrics from the software, which is instrumented with open tracing API calls. The trace, which is nothing but the root span, and the span dimension in Trace Explorer are attributes defined by tagging the span. This enables effective monitoring for various tiers of the application. After creating, so here we can have data from all the layers of the application. For example, app servers, it gives the request time, the database time, and we can also see the SQLs. And span duration, and if there are any errors. One another feature is the synthetic monitoring. To use a synthetic monitoring feature, for example, let us go to one of the monitors. Like these are also present as part of our dashboards, but it can be created from this screen. So it is a feature. It has several monitor type like scripted browser, scripted REST type, and others, where you can also upload a script which is recorded user path that is used to simulate our user transactions on the application. So after creating the monitor, you can view synthetic monitoring metrics and history on the page and monitor the performance of your application and identify possible issues before they occur. So yeah, these were some of the main features which can be used to monitor our OKE environment. With this, I will be concluding the demo. Thank you, Francisco and APAC, for hosting the event. It has been a wonderful experience and great learning for all the Oracle opportunities and products. Thank you.
CloudDB, shaping your new normal.